Notes 10A, combining like terms, linear addition. Go to joinpd.com, write down the objective and essential question. Objective, I can simplify expressions. Essential question, how do I use order of operations to combine like terms? Before we get started, let's go over the expectations for the Pear Deck. Get your Pear Deck foldable for the focus teak covered. Go to joinpd.com and join the session during class. Record answers and work for you do examples on Pear Deck slides. Complete this before you do the classwork and after the homework. Watch the video quietly with headphones or follow along on the board. On this slide, go ahead and drag the icon over your favorite country here. Vocabulary. Combine, adding or subtracting terms. Simplify, performing any given operation to reduce an expression. Term, a monomial with a coefficient and variable separated by operators, such as addition, subtraction, or parentheses. Isolate, rearranging an equation so that a different variable is on its own. The goal is to choose a sequence of operations that will leave the variable of interest on one side and put all other terms on the other side of the equal sign. On the next slide, we have some more vocabulary. Expression, a phrase that may contain variables, constants, or operations. An example is 3x plus 5. Notice expressions do not have equal signs. Expression is only a phrase. Equation, a statement where two expressions are equal. Example, 3x plus 5 equals 23. Inequality, the relation between two or three expressions that are not always equal. Employ a sign such as not equal to, greater than or equal to, less than, or less than or equal to. Example, 3x plus 5 is less than 23. Law of sameness, go ahead and write this down on your Pear Deck foldable. We have 1 cat and 3 cats. These terms are the same, they're both cats. So you put yes, cats. We have 4 pennies plus 1 nickel plus 2 dimes plus 1 quarter. Those are not the same. These coins are not the same. And we have 2x plus 2. Those are also not the same. And those are terms. Okay, now write this out. Combining like terms. We're going to combine like terms. 3 cats plus 12 cats is 15 cats. 1 dog plus 3 cats plus 2 dogs is 3 dogs and 3 cats. And is also known as the plus sign here. On your Pear Deck slide, go ahead and try this one. True or false? X and x squared are like terms. Are those the same or are those different? Choose an option. This is false. X and x squared are not like terms. Even though they both have an x, they are not the same. This one has an x, this one is x and x. Those are different. Combining like terms. Write this on your Pear Deck foldable. 14 inches plus 2 feet is how many inches? Well, there's 12 inches in each foot. So we have 12 times 2 here. So we have 24 plus 14. 38 inches. Okay, now we have 2x plus 1x minus parentheses 3 plus x, close parentheses. So first we would distribute that negative into each term. Distribute, multiply each term. We can rewrite that as 2x plus x minus 3 minus x. You want to combine the like terms, so let's circle all the terms with an x. Not x squared, just x. So the plus x and the minus x cancel out. They turn into 0 in this case. 2x has nothing else to be added to, so let's go ahead and write that on the line. 2x. And then we have a minus 3. That is a constant. So our simplified expression is 2x minus 3. Let's look at the next one. X squared minus 3x plus 4x plus 7. Our like terms are the ones with the x's. Notice x squared, there is no other term with an x squared. For the 7, our constant, there's no other term with only a number with the constant. So if we combine negative 3x plus 4x, that's the same thing as 4x minus 3x, that's 1x. So our simplified expression would be x squared plus 1x plus 7. On your Pear Deck slide, go ahead and do this one. Draw on the slide. Show the steps to simplify this expression. Pause the video, try this. We are ready to check. Unpause the video. You should have simplified it to 5x minus 1. First, we distribute that negative into each of these terms. Combine like terms. Let's box each of our terms with an x. When you're boxing terms, make sure you also include those operation signs, the pluses and the minuses. Those x's cancel out. We're left with 5x minus 1. Okay, let's do the next one here. Solving for one variable equations. So we have 5/7 x plus 1 equals 3/7 x plus 15. First, we want to see if there's anything to combine on each side. There's nothing, so let's go to the next step. Subtract 1 from each side of the equal sign. From here, 1 minus 1 is 0, and 15 minus 1 is a positive 14. Carry down the other terms and the relation symbol. We have 5/7 x equals 3/7 x plus 14. We want to get all the x's onto one side of the equation. So let's go ahead and subtract 3/7 x from both sides of the equation, both sides of the equal sign. And we can subtract these fractions because they have a common denominator of 7. 5 minus 3 is 2. So we have 2x over 2 over 7x equals 14. From there, you want to multiply by the reciprocal of our fraction. So instead of 2 over 7, we multiply each side of the equal sign by 7 over 2. 7 over 2. 7 divided by 7 is 1. 2 divided by 2 is 1. So we have 1x equals 14 divided by 2 is 7, and 7 times 7 is 49. So x equals 49. Let's look at the other example. We have 2/3 x plus 1 equals 1/3 x plus 10. There's nothing to combine on each side of the equation, so we're going to go to the next step. Subtract 1, subtract 1. 1 minus 1 is 0. 10 minus 1 is 9, a positive 9. Carry everything else down. Now we have 2/3 x equals 1/3 x plus 9. From here, we want to get all the x's on one side. So let's go ahead and subtract the 1/3 x from each side of the equal sign. 1/3 x minus 1/3 x is 0x. So those go away. Carry down our 9. 2/3 x minus 1/3 x is 1/3 x. To get rid of a fraction, we multiply by the reciprocal. We flip it. So instead of 1 over 3, we have 3 over 1. 3 divided by 3 is 1. 1 divided by 1 is 1. So 1x equals 9 divided by 1 is 9. 9 times 3 is 27. So x equals 27. Let's go back and write our steps for these. Here's our steps. The first step was to subtract 1 for both of these examples. Step 2, on the first example you subtract 3/7. On the other example you subtract 1/3. The next step, we multiply by the reciprocal. In the first example, our reciprocal was 7/2. In the second example, our reciprocal was 3 over 1. And then our conclusion is, on the first example, x equals 49, and the second example, x equals 27. On your paradox slide, go ahead and try this one on your own. Pause the video, try this one out. We are finished, check your work. You should get 15/4 equals x. First you subtract 1, then you subtract 1/5 x, then you multiply by the reciprocal. Instead of 4/5 is 5/4. 5 times 3 is 15. 4 times 1 is 4. X equals 15/4. Let's look at the next page. Write this on your foldable. We have 3 cases for solving equations here. We have no solution, a specific solution, in this case is 0, and we have infinite solutions. Let's look at the first one, the no solution. 3x plus 3 equals 3x plus 4. First, let's go ahead and subtract 3. Bring down the other terms. 3x equals 1. 3x plus 1. Subtract 3x from each side of the equal sign. We have 0 equals 1. That is a false statement. That means that there is no solution. Zero solution. 2x plus 4 equals negative x plus 4. Subtract the 4's from each side of the equal sign. Bring down our other terms. So 2x equals negative x and 0. Add the x to each side. X minus x is 0. 2x plus 1x is 3x. Divide each side by 3. 0 divided by 3 is still 0. So x equals 0. And let's look at our other case, infinite solutions, all real numbers. 5 times 2x plus 3 equals 10x plus 15. Well, first, let's distribute that 5, multiply each term by 5. 5 times 2x is 10x. 5 times 3 is 15. So 10x plus 15 equals 10x plus 15. Well, we already have a true statement here, but let's continue until we get 0 equals 0. Subtract 15 from each side of the equal sign. Bring down the rest of the terms. 15 minus 15 is 0. 15 minus 15 is also 0. So we have 10x equals 10x. Subtract 10x from each side of the equal sign. 10x minus 10x is 0. 10x minus 10x is 0. 0 equals 0. That is always a true statement. So, infinite solutions. All real numbers. Okay, now you try this one on your paired x slide. Is it no solution, x equals 0, or all real numbers, infinite solutions? Pause the video, try this one out. You should have gotten all real numbers, infinite solutions. Combine these two terms, 3x minus 1x, you get 2x. From there, we can subtract 5 from each side of the equal signs. So 5 minus 5 is 0, 5 minus 5 is 0. Bring down the 2x on this side, bring down the 2x on that side. We still have a true statement. Let's keep going. Subtract 2x, subtract 2x. 2x minus 2x is 0, 2x minus 2x is 0. 0 equals 0. That's a true statement, so it's all real numbers. Infinite solutions. Okay, now I'm going to do this one. We're isolated inequalities. Write this in your Pear Deck foldable. Solving for one variable inequality and graph on the x-axis. That's the number line. Let's look at the first one. Negative 4 is less than 5x plus 1 less than 6. So we want to get x by itself, so x needs to be by itself in the middle. So to get rid of that, we first want to subtract that 1. Negative 4 and negative 1 is a negative 5. Bring down your less than symbol. Carry down your 5x. 1 minus 1 is 0, so we don't need to write that again. 6 minus 1 is 5. To get x by itself, we have 5 times x. The opposite of multiplying is dividing. So let's divide by 5 on every side. Negative 5 divided by 5 is negative 1. 5x divided by 5 is 1x. And 5 divided by 5 is 1. So your solution is negative 1 is less than x is less than 1. To graph down the number line, we put 2 holes, and we're going to name it negative 1 and positive 1. X is in the middle, so we shade the middle part. And that's our solution. Let's look at the next one. Negative 13 is less than 7x minus 6 is less than 8. Let's isolate that x. So first we want to add the 6 to each side of the relation. Negative 13 plus 6 is negative 7. Carry down our less than sign. Carry down our 7x. 6 minus 6 is 0. Carry down our less than sign. 8 plus 6 is 14. 7 times x. The opposite of times is dividing. Divide each term by 7. Negative 7 divided by 7 is negative 1. Carry down your less than sign. 7x divided by 7 is x, 1x. Bring down your less than symbol. 14 divided by 7 is 2. So your solution is negative x is less than x is less than 2. So our number line, let's create 2 holes. Label the left one negative 1. Label the right one 2. X is in the middle, so we're going to shade the middle part. And let's look at the last example. Negative 3x is less than 12. We only have one step here, and that's to divide by negative 3 on each side of that less than symbol. Negative 3 divided by negative 3 is 1. 1x, and 12 divided by negative 3 is negative 4. So x is greater than negative 4. Whenever you divide a number with an inequality, whenever you have an inequality and you're divided by a negative, you flip the sign. That is because if you were to move this 3x to the other side, you would eventually get x on this side and negative 4 on that side. Negative 4 is less than x. These are the same solution right here. So if we're to plot this on the number line, put negative 4, and x is bigger than that, so you're going to shade the right side. Okay, now go to the last slide of your Pear Deck. Type your summary. How do I use order of operations to combine like terms? Type using complete sentences. Describe, in your own words, how to combine like terms.